Well, yesterday we reviewed some applications of trigonometry and machining type applications. Today I want to go over a few more examples of that. And then tomorrow we're going to do some more complex examples. Today, the first example I want to do is going to look something like this. So the last example we did yesterday was two round pieces of round stock inside opposing V's. Here we're going to have two pieces of round stock on V's that are facing away from each other. Let's give these angles here, we're going to call them each 54 degrees, 30 minutes. Each ball here, or each round stock, I shouldn't say ball, each piece of round stock is going to have a diameter of 0.8 inches. We are going to say that we have a spacing here of, let's call it 1.75 inches. We want to know what's the distance between the outsides of those round stock. So for this one here, just like we have anytime we have a circle in a V, and that's what we have, here's a round stock in a V groove. We draw in the diameter of this, or the radius of the circle to the point of tangency, and that forms a right angle. So we know we have a right angle there. Next, we know that if we connect the center of the circle to the point of that V, it cuts everything in half. So this angle here is half of the 5430. So we end up with this triangle that looks like this. We know that this angle here is half of the 54 degrees, 30 minutes. Well, 5430 divided by 2 goes into 54, 27 exactly. There's nothing left over. 2 goes into 30. That's 15 exactly. So that's 27 degrees, 15 minutes. This side over here is half of the 0.8. The diameter of 0.8 means it's a radius of 0.4 inches. The piece we need to find is this piece over here. That would be this distance from here to here. It would also be, of course, the same as the distance on this side, since that round stock is the same diameter. So we'll label that dimension A, and we'll find it over here. So on our right triangle here, from this angle, the 27 degrees, 15 minutes, side A is the adjacent side. It's touching our angle. The 0.4 is the opposite side, across from our angle. So opposite and adjacent make tangent. Tangent of an angle is opposite over adjacent. So then we'll fill in our information. We know our angle is 27 degrees, 15 minutes. The opposite side is 0.4. The adjacent side is side A. That's what we're looking for. So we'll put this over 1, and we will cross multiply and divide. So 1 times 0.4 is 0.4. Let's make sure my modes are set correct. Oh, in degree mode. So 0.4 divided by the tangent, 27 degrees. So I've got to spell that out. It's degrees, 15 minutes. Gives us 0.7766. We go 0.777, we'll round that 2 to 3 decimal places. That's 0.777. This is 0.777. Now we still need the distance from here to here. Well, that's just a radius of our circle. That's just 0.40 on each side. So this overall distance here across X, we have the 1.75. We have the 0.777 on each side. And we have the 0.4 on each side. So we add that all up. We have 4.104 inches. That is our dimension X. So again, it comes down to that strategy of putting in the radius of the circle and then connecting the center of the circle to the intersection of the tangents to cut everything in half. When we are dealing with these applications, the main thing that we have to be able to do is we have to find right angles. Now, I say we have to find right angles. Eventually, we have to put those right angles into triangles. But if we find the right angles first, we can generally find a triangle that fits around it. So the one strategy we've used mostly so far is the one we used up here, which is just the radius of a circle going to a tangent. And that is a very common way of finding a right angle. Another common way that we've used once or twice, and we're going to continue to use more, is just horizontal and vertical. Horizontal and vertical lines have to be perpendicular to each other. A horizontal has to be perpendicular to a vertical. Another one that comes into a play is a radius intersecting a chord. Now, it has to intersect a chord in the right manner. It has to intersect it such that it bisects a chord. Remember, that is a chord is just any segment that has its endpoints on the circle. If we're drawing our radius so that it cuts that chord in half, it also is going to hit that chord at a right angle. And as we go, there will be other strategies, but these are the three main ones that help us find right angles in our drawing. So let's look at another example here. Let's see here. We're going to do big circle, the diameter of 0.514 inches. The center to center distance between the circles is going to be 0.488 inches. We're going to draw this out here. So this line is tangent to both circles at this point down here. And the distance from here to here 2.712 inches. This is a right angle. I want to find this angle right here, X. Our right triangle here is relatively obvious. If I sketch in this radius all the way across, that forms a right angle. So this here is my right triangle. So let's look at what we know about that right triangle. We need to find some of the dimensions. Well, we know, first off, that this distance right here, all the way across, if I redraw that triangle over here, that's this side right here, is just a radius of this big circle. That big circle has a diameter of 0.514. This is 0.257 inches, half of that diameter. This side up here is simply the 2.712 minus this radius here. This is 0.257. And so if we subtract that, 2.712 minus 0.257. This gives us 0.455 inches here. Find this angle X. Excuse me. We have two sides of a right triangle. We can find a missing angle. According to this angle, if that's X, this would be the opposite side, and this is the hypotenuse. Opposite and hypotenuse just makes the sine. Sine of an angle is opposite over hypotenuse. So we'll fill in the information we have. We're looking for the angle, so it's sine of X. Opposite side is 0.257. And the hypotenuse is 2.45, not 0.45, sorry. 2.455. Now, since we're finding an angle here, we solve this by doing the inverse trig function. The inverse sine, 0.257 divided by 2.455. Second sine, 0.457 divided by 2.455 gives us 10.728 degrees. Now, since all of our other angles have been in degrees and minutes, let's do that. So 10 degrees, we'll take the 10 off of here. And the rest of it, we're going to multiply by 60 to turn it into minutes. Looks like that's going to round to 44 minutes. So that angle is going to be 10 degrees, 44 minutes. So again, we were able to find a right triangle, a right angle. Once again, here it was a radius to a tangent. Let's do one a little bit different here. Okay, so this little circle here, I'm actually going to be the radius, 0.438 inch radius. I'll tell you this is 1.520 inches. This down here is going to be 1.234 inches. We want to find dimension y down here, and I'm going to tell you that this angle here is 69 degrees and 20 minutes. So looking at this, what we need to know is this dimension across here. If I know that dimension, I'm going to call that dimension A. All I would have to do is add up these three dimensions, and it would give me dimension Y. So I have to see if there's some way I can find that dimension A. Well, we're going to construct a right triangle using that horizontal to vertical, knowing that horizontal and vertical are always perpendicular to each other. So I'm going to do that right here. I have a horizontal dimension and a vertical dimension are going to form a right angle. Now I need to see if I know any of the dimensions of that. Well, this being a radius of 0.438, that means that this is 0.438. And this is 0.438, making this dimension 0.876 inches. So in that triangle, we have 0.876 inches here. This angle right here has to be the same as this one. So this has to be 69 degrees, 20 minutes. Side A over here, if I'm labeling my triangle, is the hypotenuse. The 0.876 is the opposite side. Opposite hypotenuse is once again the sine of an angle. So I'll fill in the information I know here. The angle is the 69 degrees, 20 minutes. Opposite side is 0.876. My hypotenuse is what I'm looking for. Now here, since I'm looking for a missing side, up here I was looking for a missing angle, so I did the inverse trig function. Here I am looking for a missing side. To do that, I make it into a proportion. So I put my trig function over 1 so that I can cross multiply and divide. So it's 1 times 0.876, which is just 0.876, divided by the sine of 69 degrees, 20 minutes. Give me 0.936. So this here is 0.936 inches. So my dimension Y, 1.52, 0.936, 1.234. Adding those all up, .690 inches is my dimension Y. So again, there was a case we had to still find that right angle, but it was a matter of looking at a vertical dimension and a horizontal dimension, and where they intersected gives us that right angle. Excuse me. So these types of applications come up a lot. What we've done, the basic applications we've done, that's really all they're going to be is, it's mostly going to be that radius to a tangent and intersecting of vertical and horizontal dimensions. For today, I know this will be the third time I've given the same pages, but I want to make sure that you have done several of these applications. In that packet, it is page 358 through 361. 1 through 24, or 1 through 23, something like that, the odds. Also, to go along with that, I will have it, I don't have it posted right now, but I will have it posted within a few minutes here. There's a quiz out there that is due tomorrow. Quiz 55 and 56. Anybody have any questions? Okay, so Normally it takes like 20 to 30 minutes to work on this quiz. So usually I'm still working on kind of in-class time here. I would plan that time, so that's why we're done a little early today. Give you that extra time to work on that quiz as soon as I get it posted here. Otherwise, you have time to work on the homework, finish those up. Tomorrow, we're going to move on to more complex applications of the trig. So with that, if you want to work, I'll be here to answer questions. Otherwise,